Welcome to Aviation Integration, Topics, Tech, and Career Connections for Enhancing Math Concepts. My name is Kelly Remajan, and I'm a PD and Curriculum Specialist with the Illinois Math and Science Academy. Prior to taking on my current role, I was a math teacher for 23 years in the classroom where I taught students in title classes all the way up to honors classes. I also have worked with students of various grade levels where I have incorporated lots of the techniques, lots of the concepts and activities that I'm going to share with you in this presentation. All of the resources that I talk about, I show you, can be found at the tiny URL link that's provided on the screen. If you have any questions, please feel free to reach out to me via email, LinkedIn, or Twitter. So to get started, a good way to start talking about aviation would be the four forces of flight, that being weight, lift, thrust, and drag. So these are the four main concepts that will help us to bring in different math concepts. Now, the first thing that in terms of weight, we can talk about different sized balls, different types of balls that are of different types of material. And so for instance, you could take two balls such as a Nerf ball and a baseball, and we can compare those two things. And in terms of math, we could compare them in terms of volume or weight, or we could talk about the diameter or the width of the ball. In addition, circumference would be another topic that we could talk about. So for instance, we could ask, between a Nerf ball and a baseball, which one is heavier? So asking students what they think, what do they hypothesize? And then to determine if our hypothesis is correct, we'd actually have to conduct a little experiment to determine which one is heavier. And so a very simple experiment would be to use a balance scale. And we could see then that the baseball is heavier than the Nerf ball. In terms of comparing those two types of balls, we can also determine or compare between the Nerf ball and the baseball. If we would drop both of these balls at the same time, which one would hit the ground first? And so asking that question to students, which ball do they think would hit the ground first? We've already determined that the baseball is heavier. And so the chances are that your students, and maybe even you, would think that the baseball is going to hit the ground first. And so we can conduct an experiment to see if our hypothesis is in fact correct. So if we do that, we drop them at the same time, we'll notice that both balls hit the ground at the same time. And so we could try this activity with different types of balls, different types of sizes, of weight, and see if we get the same result each time. And asking students, why do they think that these two balls are hitting the ground at the same time? And so that has a lot to do with in terms of gravity. Again, talking about, we have spheres, we talk about the diameter, the volume, the surface area, the weight. And so bringing in those concepts, if you're talking about those different math concepts, is a great way to bring in the idea of aviation. And again, we're talking about weight being one of the forces of flight. In addition to this activity, if you're doing algebra, you could get into linear functions and talking about different types of balls in terms of how they bounce. Depending on the drop height of that ball, it will determine the bounce height, how high up the ball is going to bounce back at. And that's your bounce height. And so when we do that, we can start talking about a linear relationship. And we can also use a graphing calculator to incorporate a linear regression. Again, talking about bouncing balls, but in terms of gravity, what we drop will fall. And if we have a ball, it's going to bounce back. And so here it kind of goes through the different steps on how to graph this data using a graphing calculator. And what we have here then are our various points with a certain window size. And then we can make our linear regression, and then we can come up with the best fit line that would match our data, which you can see here. And then we could also use this to make predictions on what the bounce height would be for this particular ball when we drop that ball from a certain height. Now, we talked about weight. We talked about balls bouncing or dropping. We can also talk about weight in terms of how cargo impacts weight in aviation, as well as how it impacts center of gravity. And so you could bring in the idea of different careers. The prior activity would be almost like a scientist, where we can conduct experiments to test theories. Well, here we have more of an actual hands-on job that would be incorporating with the Air Force. Again, we could talk about load control technicians or load masters, which are involved with loading and securing aircraft cargo. We could measure weight, we could find the center of gravity, and we can use different formulas. Now, all of the links that I show here, you will find at the tiny URL that I have here with aviation-integration. And so there's some great videos and corresponding questions that you can show that have to do with these different careers. And I think it's really important for us to represent students, whether they're boys or girls, students of different races, that anyone can, if interested, can take on different roles, different careers, and those careers could all be associated somehow, some way with aviation, the ones that we're talking about today in this presentation. So you could actually have students, you could invite people to your classroom. This was an activity I actually went to a local Air Force base and spent the day with people that dealt with cargo, learning about how they used math. But you could have those people come to your classroom. And we worked with air cargo, specifically with vehicles. And so we used these scales to collect data, and then we used formulas to determine the moment. You could talk about what that is. You could talk about center of balance, and in terms of where the center of balance is for this vehicle. That all has to do with how we secure that load within an aircraft. Again, every aircraft, not just vehicle cargo, but every aircraft has a center of gravity. And so here, what we have, this circle is representing the center of gravity for this aircraft. Again, it may not be the actual center of the aircraft, but it's the center of gravity, because you can talk about, you have the aircraft, you have the weight of the engine, you also have the weight of the fuel, which most likely is actually inside the wings of this aircraft. And so bringing in those concepts of not just cargo, but aircrafts have a center of gravity. Bringing in more of the math components, if you're teaching geometry, is you could talk about the center of gravity, not just with airplanes, but with different types of geometric figures. And here we have a circle. And so the center of gravity of a circle is the center point of the circle. And so if you identify the center of a circle, then you can find the balance point. So that circle is balanced by putting the pencil at its center. An extension for this for high school, you could actually have the students find the center of a circle, and that to do that, you could have them construct the perpendicular bisectors, and where the two perpendicular bisectors of two chords intersect, that is going to be the center of your circle. Now, in addition to circles, we could also talk about triangles. Again, the center point, the center of gravity is going to be a balance point that is the location within this triangle. And what I have here, I worked with a scalene right triangle. It could be any type of triangle, and you can find what's called the centroid of that triangle. And that's where we have the three medians of the triangle intersect. And a median is a segment connecting a vertex to the midpoint of the opposite side. So being able to show you this, I'm cutting out my triangle, and then I'm going to use my pencil or a marker, and I'm going to find the median. So that's one median. And just to identify, what I just did is I found the midpoint of a side of the triangle, and I drew a segment from the vertex to the midpoint of the opposite side. Since I have a triangle, there are 3 sides, so there are going to be 3 medians. And where those 3 medians intersect is going to be the balance point for our triangle. And so that is going to be the center of gravity. And so I'll be able to find the point, and I'll be able to balance that triangle on a pencil at that centroid. Again, it's the center of gravity, just like an airplane has a center of gravity. Cargo has a center of gravity. Our various geometric shapes will also have a center of gravity or a balance point. Fuel impacts weight as well. Fuel distribution specialists and in-flight boom operators use the idea of fuel. The fuel distribution specialists are the ones that actually load the plane with fuel, but a boom operator is a person that actually will sit on their belly inside of an aircraft looking outside the back and will help fuel another aircraft in mid-flight in the air, which is pretty cool. And so using the idea of multiplication or proportions, we could have students identify the weight of fuel and introducing these careers to them. You could ask them, how does a plane's weight compare when taking off versus landing? And that's the fact that when a plane takes off, it's going to weigh heavier, it's going to weigh more because it has its fuel inside the aircraft. But when it lands, it's going to be lighter because the airplane has burned off some of the fuel. In terms of forces of flight, we can talk about drag. The drag of an aircraft can slow the aircraft down. You could do different types of experiments with umbrellas in terms of speed. And you could talk about another type of a career, that being an aircrew flight technician. That could be a career where they actually are going to pack these parachutes or these drag chutes within aircrafts. Very familiar activities involving parachutes can be used. You could expose students not only to parachutes when you're jumping out of an aircraft, but how these parachutes or drogue chutes are used in spacecraft to be able to land the spacecraft on Earth, and incorporating the idea of engineers, whether you're an aerospace engineer or an aeronautical engineer. Now, in terms of lift, which is going to be helping the aircraft rise up, we can get involved with or expose students involving with the Bernoulli's principle. And so again, aeronautical engineers, aviation mechanics need to understand the principle, the Bernoulli's principle in their career field. So let's take a look. So here we're talking about, again, lift. And we could be talking about spheres. We can incorporate the ideas in science with air pressure and gravity. And so we have the lift, which is going to be the opposite of gravity. So we have gravity that's going down, the weight, and we have the lift going up. You could have students find the volume of 2 ping pong balls or the surface area of 2 ping pong balls. You could also, again, incorporate the cylinder. We could talk about the area in which this ball is going to pass through, being the area of a circle. And we can talk about the volume of this cylinder, the amount of air that's going to pass through this cylinder, the volume of it. So taking a look there. What happened? And that is that this ball, this ping pong ball, is shooting through this cylinder. Again, bringing in different science concepts, integrating them with math concepts, talking about aviation. So in addition to thinking about air, we can also talk about how wings are utilized to help with the lift of an aircraft. And the wings must be maintained. So you could talk about the different types of shapes of wings and how they relate or how they compare to birds. You could talk about the different shapes and the different types of airplanes that have these different shaped wings. And you could have them find the area. And you must be able to calculate the area of these shapes. If you want to increase the area, you're going to increase the lift of that aircraft. Being able to incorporate not only finding area, but using the different terms in terms of wingspan or wing chord, root chord, or tip chord when you're having students doing these types of problems involving area. In order to maintain, you can talk about aviation mechanics, how they're used to repair wings, and how sheet metal is a huge component within their career field. In addition, you could talk about the different types of controls within the aircraft that pilots use to be able to move their aircraft to be able to produce that lift. Rudder pedals will be able to move rudders, which help to, if you think about the rudder for a boat, it's going to be able to move the aircraft in the direction that you want. And to make sure that the aircraft will fly appropriately, you'll often will have aircraft mechanics will put on patches on the sheet metal of aircraft to make sure that that plane is going to fly properly. And so you can incorporate different types of problems. This was a problem that I made up my day of exploring aviation mechanics at Southwestern Illinois College to learn about all the math that's involved in this career field. And so you might have a circular patch, and you have to put on that patch 16 rivets for the outermost portion. And you can get in terms of the angles that are associated here and the different terminology in terms of rivets and fasteners to be able to fasten this patch to an aircraft. You could also have students actually do hands-on activities using drills. I always think that anytime a student can actually use tools is a great learning tool in addition to using the math. And so they can use different drill bits of different measurements, and you could have them use Amazon boxes and drill holes in those boxes. You could have them create a patch using to be able to cut out a 3-inch by 3-inch square on an Amazon box, and then be able to just simply drill 1/8 inch holes and drill 3 32nd inch holes, and then determine prior to that how many holes that they're going to need to create within this patch. Also with lift, you could incorporate terminology such as the fuselage, the length of the fuselage if you put those images on a coordinate plane. You could talk about slope of ascent, and again, the different types of controls that pilots use to be able to raise the nose of the aircraft, and being able to angle it up helps with that lift. And in terms of the elevator being able to rise, again, helping raise the nose of the aircraft. So pilots and mechanics need to understand this terminology. I would highly encourage you to install the Google Earth Pro to your computer, and Google Earth Pro will allow you to use a flight simulator within your computer, which is a great tool for you as well as your students. They can explore an F-16, or they can explore an aircraft with a propeller as well. And so just going through that process, installing it, and playing around with the in-flight simulator. You can also join the Civil Air Patrol as an aerospace education member for a one-time fee of $35. And if you do that, you can apply for a free flight simulator kit, which looks something like this. And by being a member, you have access to resources. They send you a bunch of different books and workbooks, and you have access to guest speakers that could come to your class, as well as information that you can pass on to students about the different opportunities available to students as well that are interested in aviation. becoming a pilot or being connected to the aviation field one way or another, whether it's flying a plane, flying drones. There's lots of different opportunities with Civil Air Patrol. Now, in terms of thrust, which helps move an aircraft forward, you could have students, or you could build a propeller car. And I purchased a propeller kit at the link that you'll see here. And I built this car that you see. This was a 4-inch propeller, and the propeller measurement has to do with the diameter of that propeller. And so you could build this car and you could ask your students, what happens when the propeller spins? You can then have students conduct an experiment. You could also talk about distance, rate, and time within that experiment. And so these propellers are like twisted wings that are going to help move the aircraft forward. Again, this was a 4-inch propeller. You could have a different measurement for a propeller and conduct different experiments. You could have propellers with different numbers of blades. And so there's lots of different experiments that you can do that helps to bring forth the math and to also talk about aviation mechanics as a potential career field that might be of interest to students. Another great free software that you can use is physlets.org/tracker. And this is a free software that you can do video, and that tracker software will allow you to collect data from your video. If you do this, however, when you do video, you want your video, your computer or your camera to be stationary, and you want within that video a standard unit of measure. So here I have a meter stick, and you want to make sure you have that, because then that'll help to collect your data to be more accurate. So let me just show you here. This is the same propeller car. It's video from a different direction. I'm collecting points, and even though this propeller car is moving in a horizontal manner, when I collect my data, Physlet's tracker allows me to acquire different types of graphs. And you can see then from my graph that it's not a horizontal line. And so you can be able to show students this information. It'll allow you to collect data, it'll allow you to make graphs, but you can also do various algebra components with this data as well. And so this is comparing time as my horizontal axis and my X in terms of my horizontal displacement. In addition to thrust, not only with propellers, we can also incorporate an activity involving balloons that helps us to make the connection with not only propellers helping to move aircraft forward, but also the engines, especially with jet planes propelling the aircraft forward. And so what I have here is I'm able to use a piece of string, and I can talk about ratios, vertical rise to horizontal distance. I can talk about slope of ascent. I could talk about angle of elevation. And so being able to incorporate these concepts and to conduct an experiment, whether it's you or your students, it's a great way to bring in the math with the aviation integration. And so that balloon, I had it attached to a straw that was within that, the string went through the straw, and that propelled the straw forward. That balloon gave the thrust forward. The air is pushing back, which allows the aircraft to move forward. Other connections beyond the forces of flight, we could get into flight time, which is a great concept, whether you're in 5th grade or if you're in high school, talking about integers, adding and subtracting. You could also talk about angles. But if a plane leaves Illinois, at Illinois being here, for a 2-hour nonstop flight to New York, you could have your students determine what time the plane would land in New York. You could have them determine the angle made by the hands of a clock at 5 o'clock, as well as the angle made by the hands of the clock at whatever time that plane is going to leave or going to arrive in New York. So it's a great way of adding and subtracting, or simply with working with integers or with angles, depending on the concepts that you're wanting to focus on. These flight time has to do with flight dispatchers, air traffic controllers, people that are in the control center, making sure that planes are leaving and arriving at the time that they should, or inquiring about what's happening that's causing these planes to not arrive at the time that they're scheduled to. In addition, other connections, you could talk about headwind versus tailwind. And so this is an example of how I have incorporated different career notes within my examples or within my student worksheets, student activity sheets. And so when we have a tailwind, we're simply adding the speed of the wind to the speed of the aircraft. If we're talking about a headwind, we can add a negative integer, or you could simply subtract the speed of the wind. And then you'll see here, I have just a simple note that talks about different careers or different opportunities that are available to students, so that they can, a lot of times students get finished early. This is a little note that might get their attention, and I can just simply talk about the local community college that has an aviation department and the amazing opportunities that exist for people that go into aviation, whether you're a pilot or an aviation mechanic. Other connections, you could talk about meteorology, and you could talk about how the wind typically blows from the west due to the Earth's rotation. And the wind, the direction the wind comes from is usually how we identify the wind. So if our wind comes from the west, those are westerly winds. You can also expose students to the idea of vectors. And if you are, let's say, a fifth grade teacher teaching the states, and you're talking about the state names and the capitals, this is just a great way to expose, to bring in the idea of aviation, flying from one state to another, and one capital city to another. And in terms of, you could have students look up how long of a trip it would take to fly from, let's say, Missouri to Maine, or Maine to Missouri, and how usually flying from the west, from Missouri to Maine, is going to take a shorter amount of time than Maine to Missouri. And that's because of the wind, having a tailwind versus a headwind. Other connections, when I met with individuals that were going through aviation training to become pilots, I asked them, what would be a topic that you really wish that your teachers would bring forth in just a regular classroom? And one thing that they had shared was the idea of the aviation alphabet. And so simply naming points, if you're plotting points on a coordinate plane, or naming angles, or simply putting students into groups, using the aviation alphabet is a real simple way to expose students to aviation concepts. So if you have an angle Alpha, Bravo, Charlie, or if you have groups, you assign groups. In my classroom, I always had letters of groups on the ceiling. And so I have Group A, or Squadron Alpha, Alpha, Bravo, Charlie, Delta, Echo, Foxtrot. Or if you are going to have naming triangles. Another way of incorporating is being able to talk about the tail numbers of aircraft, but also to talk about how airports have 3 letters that identify that airport. So the St. Louis Lambert International Airport is STL. But if you go to Chicago, Chicago O'Hare International Airport is not CHI. And so you can have students kind of explore the 3 letters that identify the airports. And so if you go to an airport and you bring your baggage, they most likely, wherever you're traveling to, will have like a tag on it that will identify the airport in which your bags are going to be flown to, and it's identified by 3 letters. And so a great way to make connections with points, angles, groups within a math classroom. Another connection, whether you're a flight dispatcher or air traffic control or a pilot, is being able to talk about the flight profile for an aircraft and how this connects to linear functions. You have your takeoff, which is like an increasing function. When your plane is en route, that's a constant function. And when it's starting to descend or approach, that's going to be your decreasing function. And of course, when you land, again, that's your constant function. Air traffic controllers, the concepts that allow us to talk about those career fields would be the idea of cylinders and an actual plane, the plane crossing a plane here. Air traffic controllers cover a certain region, which is often depicted by a cylinder. And when that airplane crosses an imaginary plane, another type of air traffic control system will take over in terms of monitoring and assisting pilots as they fly to their destination. Air traffic controllers and pilots utilize these types of maps. They're called aviation navigation charts. And within those maps or those navigation charts, you'll often will see concentric circles. And so this is what it looks like on your map or your chart, but this is kind of what it resembles. It's almost like an upside down wedding cake. And what we have are cylinders. And so concentric circles and cylinders can be brought forth within a math classroom. When landing an airplane, air traffic controllers assist, and the idea of headings and runways come into play. And so no matter what level, if you talk about directions with north, east, south, and west, it's a great way to talk about directions in terms of numbers. So if you're headed in an east, you're heading easterly, you're heading in the east direction, you could talk about that being 90 degrees. South is 180, west is 270. And if you're heading southwest, maybe you're heading in like a 225 degree heading. And the heading is also associated with the runways. And so if you're headed in a 230 degree direction, you might be landing at runway 23. Runway 23 is a 203 degree heading. Parallel lines is a great way to talk about runways, that some runways will have the same number, but they'll be identified with an L for left or an R for right. So we have parallel runways. This is 12L and this is 12R. They're parallel. Google Earth, I would highly encourage you to explore Google Earth, and we can bring in the idea of shapes. We could talk about runway numbers, headings, and we could also measure runways. So what you can do is you can explore your local airport. Mine would be the St. Louis Downtown Airport. And when we explore that, it'll allow us to zoom in on whatever airport you are wanting to explore. So you'll see different shapes looking at it from the aerial view. And the bottom right-hand corner here, you'll see a little arrowhead, double arrowhead with red and white. When that arrowhead, if you click it, the red arrowhead's pushing up. That means now we're looking that north is up and south is down. And so now it kind of helps us to orientate. And you can maneuver your mouse. You can also, if you wanted to, this right here, this symbol, if you click on that, it allows you to measure different things that you see, whether they're runways or the different hangars that are visible from your view. You'll also see, again, besides that number, you'll see different numbers that are associated. You'll see here 12R. So there's probably a 12L as well, because if there's an R, there's going to be an L. And so again, maneuvering around, you'll see 12L here, and it allows you to bring in those heading connections within your classroom. Intersecting circles is basically the concept that is associated with GPS. And you need at least 3 satellites to identify your location. And airplanes utilize GPS to identify where they are located. And so if you know, just like if you're in a car with GPS in a phone or the GPS within a car, the car or your phone is utilizing how far you are from at least 3 satellites. And depending on that distance is going to help identify your location. Where those 3 circles intersect is going to be your GPS location. And so if you're talking about intersecting circles in a geometry course, this is a great concept to bring forth. You could do it by hand, which this is a great resource to use by simply using string, and you can use a paper clip as well to identify location. You could use online software involving geocaching, which I would encourage you to utilize this resource. Again, this link is available to you at the tiny URL that I've provided. And so if you know your location, or if you know the location of a satellite and how far you are from this satellite, how far you are from this satellite, how far you are from this satellite, you will be able to determine over what city your plane is located. And in this case, it would be Denver. And so where those 3 circles intersect is going to be your location. Now, cybersecurity is needed in aviation. A GPS can be hacked. And so it's very important for aviation to have cybersecurity analysts. And a hacker can actually do what's called spoofing, where it can make planes look like they're in a different location. And so there are lots of connections with cybersecurity in terms of binary math, being with zeros and ones, with the decimal system, our base 10 system using 10 digits, versus a binary system, which is going to have 2. It's going to have 2 numbers, 0 and 1. And so there's a lot more that can be involved here with binary math in terms of exponents and place value. If you are simply talking about division, you're talking about improper fractions, you're talking about remainders, this is a nice little activity that helps us to change any base 10 number into a base 2 number. And so if you take a number such as 13 and you divide it by 2, or in other words, you take it and divide it in half, you get 6.5. We ignore that remainder, and then we continue with 6. We divide it by 2, we get 3. We take 3 divided by 2, we get 1.5. We're again going to ignore that remainder, and what we're going to end up with is 1. So you could take any number, whether it's 13, 25, 100, you are going to continue to divide a number by 2 until your result ends up being 1. And then once you end up with 1, what you'll be able to do is take these series of numbers, and we're going to, under any odd number, we're going to put a 1. And under any even number, we're going to put a 0. So this is odd, odd, even, odd. And so being able to expose students to even and odd numbers and converting numbers from the decimal system, base 10, into binary. And so again, and under any odd number, we're going to put a 1. And under any even number, we're going to put a 0. And so a base 10 number of 13 is actually 1101 in binary math. There is a video again that you can utilize that helps to explain that. There's also a resource that helps talk a little bit more about binary math. And so number of possibilities, you could have students write their name in computer language in terms of bytes of memory, which has to do with binary math as well. And so lots that can be talked about with binary math, but this is a little activity where students can write their name in binary numbers. ArcGIS is a tool that ArcGIS analysts use. Pavement engineers use GIS software to be able to map their runways. You can have your students do activities involving ArcGIS. There's lots of free activities that you can see here with this resource that utilizes satellite imagery and has students do different activities. Airport wildlife biologists use GIS software as well. They're able to map, to monitor where birds are, and then they can put out mobile cannons that blow to scare off the birds, because birds can be harmful to aircraft and can cause accidents and crashes. More with ArcGIS analysts in terms of software. There's a great video here that talks a little bit about how they're using ArcGIS software to map out the surrounding trees, because trees can be obstacles for aircraft that are taking off or landing. And you can also incorporate the idea of trees with having students find the height of trees, whether they're estimating it using the height of a person, using software through NASA that can be done on a smartphone app, or using the idea of an isosceles triangle to find the height of a tree, as well as a clinometer. And again, I have a link that you have access to this clinometer for. You could also incorporate trigonometry, specifically with the tangent function to figure out the height of trees. Connections with trees, with helicopters, lots with helicopters and rotor blades. You could have students conduct an experiment with helicopters of different types of rotor blades, and having students determine that the helicopter that we use that has a greater surface area for the rotor blades is going to stay in the air longer because of its air resistance. You could have students find the area of these two rectangles or the area of these two triangles. More with helicopters can then lead into the idea of drones. And you could have students utilize these small quadrocopters. You could have them land them on a coordinate plane if it's within a classroom, or you could use chalk outside. But I always say doing things inside makes it a little bit more manageable and easier to plan. You can have them identify the coordinates of ground control points. You could have them landed on different types of landing pads. And these are connections with drone pilots in terms of where they are going to land their drone, and also to identify their different waypoints, how that drone is going to fly, its actual flight plan. Accident reconstructionists, such as in the Illinois State Police, use drones to collect data at crash scenes. And so you can utilize drones and expose students to crash reconstructionists. You could have them find the area of a crash scene. You can have them identify where the drone needs to be flown to for a certain crash site. And you could have them figure out how much time it would take an accident reconstructionist to survey a crash scene based on information that they're given. There's lots of information that can be used and can be then put into a computer for 3D modeling, which can be done and has been done by the police within a certain case. If they have to show things three-dimensional wise in a court of law to help present a case. Also within accident reconstructionists and drones, you could also incorporate the idea of inequalities, and that the aircraft, the drone, has to be flown below 400 feet. And so that can be represented as an inequality, or it can be represented as a compound inequality, because that drone is not going to be flown below the ground. And so it has to be what I call an in-betweenie. The Illinois State Police crash reconstruction team usually fly between 70 and 120 feet to get their information. So being able to talk about these types of concepts, if you're talking about inequalities, bringing in the idea of careers and how they connect makes it more meaningful for students. Machinists are also used in aerospace engineering. You can have students see whether a machinist that makes different things that they've seen before, whether it's fidget spinners, artwork, a guitar, or different parts on an aircraft, whether they're small or big, on a rocket. Aerospace engineering, I have illustrated using the idea of having students make different designs, writing a program to match their design, testing the program using free online software. And I've done this activity with 5th graders all the way up to high schoolers. This is a CNC machine that I had a local community college bring to my school when I was a teacher at O'Fallon Township High School. This machine is going to cut out material versus a 3D machine, which is going to add material. And so just to show you a little glimpse of what's going to happen here is we can put, in this case, a rectangular piece of wood down, and we're going to use a program, use a USB device to read our program that the students developed. Once we have the wood in place, we can then get out our controller with our programs, and then the machine can simply run the program using what we have programmed. We're going to hit OK. The drill's going to go down. And what you have at the end is a image that says fun. Students came up with their own designs, what you can see here. And this particular student liked the band BTS, which is a K-pop band. This student was really into Thor. I don't know what, I forget what this thing is called, maybe the mallet. The student liked cats, so she created a design, programmed it, and used the machine to cut it out. And it was nice to see that these students wanted to do something for her mom, and he wanted to do something for his dad, whose birthday was coming up. So they designed, and then they machined their designs using what's called a CNC machine, or computer numerical control. There's lots of things that students could design. You could connect different cultures, different countries, this being the flag of Somalia, located in Africa. And this is a little video that kind of shows how you can use an online resource to test your program. So you could have students create their program in Word or in PowerPoint, and then they can simply copy that program that they have written, and then they can paste it into ncviewer.com. And once you plot it, you can see whether or not your program is going to create your intended design. This is another type of machine that a local community college has to create that image that you see here. And so different community colleges have programs that students can get into. And actually, many high schools have programs where they have CNC machines. And so you might want to investigate your local school or your district to see if your school even has some of these machines. My school, O'Fallon High School, did, and I did not even know. And so it's a great way to partner with teachers within your school, or to partner with local community colleges, or even businesses that have CNC machines. I would encourage you to utilize teacher resources and guest speakers from various organizations, which I have lots of them listed for you. There are opportunities for students to actually take free flights through different organizations as well. But this gives you a taste of how you can integrate aviation concepts within a math classroom to expose students to connections as well as potential careers and pathways after high school. I would greatly appreciate if you could provide some input via a 2-minute survey at the link provided. Your information, your feedback definitely helps me. Again, thank you so much for attending this presentation. All resources can be found at the tinyurl.com/aviation-integration. If you have any questions, please feel free to reach out to me via email, LinkedIn, or Twitter. Enjoy the rest of your conference.